So this is chapter 19, Atoms, Molecules, and Extended Bonding Substances. And this chapter has a lot of vocabulary in it that you'll need to know, and then a few more in-depth materials that we'll cover. So to start with the vocabulary, we have our pure substances, and these are anything that are a regular and repeating kind of pattern. It's your molecules that have a definitive structure, so like your sodium chloride is always NaCl. There's no changing it, it will always be NaCl. Then you have your elements, which are just your simple elements off the periodic table. So you have your hydrogen, you have your chlorine, you have your potassium. Any one of those is considered an element. And then we also have our compounds. And so this is two or more atoms attached to each other. So this is when you can have water, which has H2O. You have carbon dioxide, which is CO2, and nitrogen, which is N2. And the thing to know about compounds is what these subscripts mean. So on a subscript, this 2 tells me that I have 2 atoms of my nitrogen. I have 2 atoms of my oxygen and then 1 atom of my carbon dioxide. Or I have 1 atom of oxygen and then 2 atoms of my hydrogen. So just make sure you know the subscripts. The other vocabulary word to know is a mixture, which is exactly what it sounds like. It's just taking 2 materials, mixing them together. They don't really bond, they don't react it, they're just mixed. And then solutions, on the other hand, this is when I have a liquid matter and a solid matter, and I dissolve my solid matter into my liquid. And then we also have alloys. So alloys are when I take 2 different metals and mix them together to form a new metallic bond. So brass is an example. This is copper and zinc mixed together. And we really like alloys in infrastructure because they take all the good properties of the metals and really kind of cancel out the bad. So they're a lot stronger. They're like steel we use a lot for infrastructure because it's really strong. So alloys are good. We like them. The other thing to know is atomic matter. This is along the lines of your elements. So anything that has a whole bunch of atoms of the same element. So hydrogen, oxygen, fluorine, it's all one element. Molecular, on the other hand, goes along with your compounds. This is when I have 2 or more elements combined to form a molecular structure. So water is H2O, carbon dioxide is CO2. And within a molecular bond, we can also have sharing of electrons that will create single, double, and triple bonds. So a single bond shares 2 electrons. A double bond has 2 sets of electrons being shared. And a triple bond has 3 sets of electrons being shared. And then the last matter is your network matter. This is when you have a block structure. So with gold, I just have a block of gold. And then with sodium chloride, this is an ionic bond. This is going to be a block of sodium and chlorine where I have alternating charges, and that's what forms the block. So I have this positive, negative, positive, negative, positive, negative structure. So those are held together, both of them with the electromagnetic force. They're very strong, very high melting point matter with networks. The other thing to know is your mass spectroscopy and your IR spec. So mass spectroscopy is when we don't know what a substance is, and we want to figure it out. And so we can take these molecules, put them through a particle accelerator, and break them apart. And by doing so, we're going to end up with a bunch of different masses because we have all these different pieces of different sizes. So think of it as like going through campus with a bag of Oreos in your backpack. And throughout the day, you're going to be throwing your backpack around. The Oreos are going to get broken up. And because of this way they're made, you know, you have your 2 cookies and your cream, they're going to break in certain ways. I'm not going to end up with 2 separate cookies in my cream. That just won't happen. Usually it's going to be my cream attached to a bunch of crumbles. It's going to break, you know, cleanly in half. You just have a lot of different ways that it's most likely to break into. And then throughout the end of the day, I still can have a whole cookie. So for the mass spectroscopy, I have these pieces that show up a lot, but at the end of the day, I can still have the whole molecule show up. So the very last line is the mass of the entire molecule. Then IR spectroscopy is also another way we can identify molecules. Every IR spec is individual to the molecule. Same with mass spec, they're individual to the molecule. So in this case, this is an absorption spectra, and we can get the graph form of the absorption spectra. So with the red, I have a lot of the red being absorbed here, so my graph is going to dip because I absorbed a lot of it. And then it's going to come back up because I'm not absorbing any of the yellow. Then it dips because I absorbed some of the green, come back up, and then it dips again because I absorbed some of the blue. So it's just the graph form of your absorption spectra. And that's chapter 19.